Hi, we're going to be looking at section 4.3, which is permutations when all objects are distinguishable. What that means is we're looking at when we're rearranging objects where each object is unique and distinct, so we don't have any objects that are the exact same as each other. So this deals with how many ways we can pick X objects out of a group of Y objects and arrange them differently. So for example, we might have to choose, say, 4 things out of a group of 15 and come up with how many possible ways we can A, make that choice, and B, arrange them. So the combination of those two things. So for example, calculate how many ways 12 competitors can finish in the first 3 positions of a race. Now we want to show how this can be represented with factorial notation as well. And then we want to come up with an equation that will work in any scenario. Okay, so part A, how many ways 12 competitors can finish in the first 3 positions of a race? So we've got 3 positions at the front of our race, first, second, and third. So we've got 12 competitors, so we could say we've got 12 different options for who finishes first. Now, if we've already chosen one person to finish first, that leaves us 11 possible people can finish second. Now, if we've chosen 2 people to finish first and second, that's going to leave us with 10 possible people that can finish third. So that's going to give us 1,320 different ways 3 people can finish in the top of 3 of the race. Part B, we're going to change this into interval notation, or sorry, factorial notation. So we know this is decreasing by 1 each time, so we're just going to put 12 factorial. And then based off of what we did in the last section, we know that because this stops at 10, that means we're dividing it by 9 factorial. Now, if we enter 12 factorial over 9 factorial in our calculator, it should give us 1,320. Part C is we want to come up with an equation for this. So in the past, we've been using essentially just n factorial for what's in our numerator, so we'll continue with that. So we've got n factorial here. Now, we have to think about how we created this here. How we figured out what this number was. Now, essentially, we knew that we had essentially 12 factorial, but missing the first 3 terms up here. So 1, 2, 3 terms. So essentially we had 12 minus 3, which gave us this 9. So what we can do is say that n factorial over n minus, let's give another variable, let's say r factorial. So n factorial is our number of, in this case, people competing. And then r is how many positions we're looking for. So in this case, 12 people competing, 3 positions. So 12 minus 3 gives us that 9 factorial. So with this, we'll add that where n is the total amount of objects. And r is the amount chosen. Now, this is actually a formula that corresponds to what's known as permutation notation. So we have NPR is n factorial over n minus r factorial. So that's this equation we came up with on the previous question. So, for example, we could write it as 50p10, which would essentially mean we're choosing from 50 objects 10 and seeing how many ways we can arrange from. Now, many calculators have this notation in them. To utilize this notation in a Texas Instrument calculator, typically you'll put 50 in, then you'll go math, select, go over to right until you get the PRB menu, go down to the second option, which is NPR, and then we'd write the 10, and then it will hit enter, and it will give us what this is equal to. So, an example, an internet website requires a 6 to 8 character password using lower and uppercase letters and numeric digits. If each character is only used once, how many passwords are possible? So first thing we need to do is figure out how many characters we can use. So we're using upper and lowercase letters. We know that our alphabet has 26 letters. So we've got 2 times 26, plus we've got all of our numeric digits, so plus 10. So we've got 62 possible characters. Now we can use this formula we just came up with because we're told we're not allowed to repeat any things. Now, one thing that adds a little bit to this question is that requires 6 to 8 characters. So what we're going to have to do is figure out how many 6-character passwords are possible, how many 7-character passwords are possible, and how many 8-character passwords are possible. So for 6 characters, if we use that notation that we just came up with, we're choosing from 62 characters, and we're choosing 6 from it. For 7 characters, we are once again starting with 62, and we're choosing 7. For 8 characters, we are once again starting with 62 and choosing 8. So therefore, our total is equal to 62 P6 plus 62 P7 plus 62 P8, and putting this in our calculator should give us the very large number of 1.39 times 10 to the 14. So this is how many possible passwords can be created using the guidelines given here.